Hello everybody. We're here to talk about how to measure volatile acidity with a cash still. So let me take you through all of the materials and methods and things that you're going to need to do this. So first off, we have to look at the piece of equipment. This is an R&D glass cash still. And the way a cash still works is it's a steam distillation unit. So you have boiling water down here that gets pumped up through the sample. Then the sample comes off the top and down and through this column where it recondenses and falls into the glass. Why this works is that volatile acidity is just that, it's volatile. The other acids in the wine are fixed acids. They can't come off. So the volatile acidity gets distilled off, condensed, dropped into this container, an Erlenmeyer flask, and then we can titrate it. So that's the science behind it. The other materials we're gonna need is we're gonna need some phenolphthalein indicator. We're going to need a little bit of hydrogen peroxide. We're going to need some 0.01 molar sodium hydroxide. We're going to need 2 Erlenmeyer flasks. We're going to need distilled water. And we're going to need a burette full of that 0.01 molar sodium hydroxide. We need a 10 ml pipette and a pipette bulb. So the way that this analysis works is it's very complicated, all of the different things that you have to do at the right time. So let's be really clear on something. This is a nice glass piece of equipment, close to $1,000, and it's easily breakable. So don't force anything, don't push it, don't overdo anything, be very, very careful. So before we start with this, the first thing we want to do is there's a little black line on all of these stills. And this will allow you to do 2 analyses. You'll have to do 2. You'll have to do one that's a blank, and you'll have to do a second one, which is your actual sample. So the first thing that we do is make sure that our still is totally full of water. Do not turn it on, do not touch anything before this is full of water. The second thing you need to do is verify the position of these 2 stopcocks. The one on the funnel needs to be horizontal, and the one on the exit chamber has to be vertical. So notice that this has a little red mark on it. We'll talk about that in a second. This one's horizontal, this one's vertical. So the next thing that we're going to want to do is go ahead and turn on the unit and let it start warming up, because that's going to take a minute. And then the first thing that we're going to want to do is prepare our samples. So in order to do that, we need to put about 50 mils of liquid into each of our Erlenmeyer flasks. One of these is going to be for our sample, and one is going to be for our blank. So the first step is to put in a little bit of water, and then a little phenolphthalein indicator. And just a few drops is plenty. Then after we do that, we're going to go ahead and take a little bit of this 0.1 molar sodium hydroxide that we have in our burette here, and just put a little drip in there and swirl it until we get a nice pale pink. We don't want it too flashy pink. This is probably a little too pink actually. So what I'm going to do is mix it with the other sample and pale it back, pour it back over so that we get a nice pale pink. So you see how we have this really pale pink? This is important to remember this color, because this is what we're going to end up titrating back to, is that really nice pale pink. Now, I've turned on the unit, so it's starting to warm up. But one thing that's really important, and something I'm just trying to keep quiet here, is we're going to have to turn on the condenser, because we're going to make steam, and this condenser has to have cold water running by it. So I wanted to get as much audible stuff out of the way. But generally, when you first start running this analysis, the first thing you'll want to do is walk in and turn on the condenser. We'll get there in a second. So our next step in running our blank is we want to keep everything as if we're doing a real wine sample. Except we're going to do it with water. So we first take our 10 ml pipette with 10 mils of water in it and put it up here in the funnel on top. Okay. Then our next step is going to be to go ahead and put our Erlenmeyer flask underneath, under the catch, because this is where the liquid's going to come out. And we'll go ahead and turn the stopcock so that our water goes down into the still. And you take the red handle right here and turn it up. Remember, take the red handle and turn it up. And that'll drain right into the boiling chamber. I'm going to go ahead and turn on the condenser now. And we'll probably have a little background noise. All right. Notice the water starting to boil. And then what will happen is that we're going to have it start to boil. We'll have some steam come through and boil off the water and condense it over to here. So that's step one. So I'm going to go ahead and pause the video until we get our distillate. Okay, we're just like that. About 5 minutes has gone by, and we've been boiling the whole time, and we've been having some of the steam come over. It condenses, and you can see it collecting down here in this Erlenmeyer flask. And we started with 50 mils, and we're going to want to collect about 100 mils of distillate. So we're coming up on that amount right now. So this is 150 mils of distillate, this is 50, and then this is 150 right there. So we'll want to collect about 100 mils of distillate. We're coming up on that really quick. So once we get that 100 mils of distillate, we're going to go ahead and turn off our still and let it go ahead and stop boiling and let it cool on down. And then while it's cooling down, we'll want to open up this valve right here and turn this to horizontal. And that'll create a vacuum, and it'll suck out the water sample that we were just boiling. As soon as we're done with that, we immediately want to turn that back up vertical. Then we'll go ahead and remove our sample flask, and we'll just set that aside for a minute, and I'll talk about how we do that in a second. Then our next step is to go ahead and put the other Erlenmeyer flask underneath, and now we want to prepare our wine sample. So we get 10 mils of our wine sample. We put that up here in the funnel. Now again, make sure that the stopcock is nice and level. We'll go ahead and put our 10 milliliters of wine in here. All right. Our next step is to put a small drop, just one drop of hydrogen peroxide up here to bind up any sulfur dioxide that might come off, because the sulfur dioxide might come over as sulfuric acid. So we want to bind up that SO2 as sulfuric acid right here, so that when it distills off, sulfuric acid is a fixed acid and it's not going to come off and mess up our results. So our next step here is to make sure that we have a little bottle of distilled water. We're going to turn the red handle straight upright. And then we're going to rinse that down in there to make sure it all gets in the still. We're going to turn it sideways, and then we're going to go ahead and turn on our still. Now, a couple things that I see that are mistakes that happen pretty regularly is, number one, people open this and accidentally leave it open, and then what will happen is all the steam will come out and throw off your results. And another thing that happens pretty regularly, which is kind of hilarious, is people leave this stopcock open, they pour their wine in, and it immediately gets sucked right out and down the drain. So we don't want to do that. So we're going to go ahead and turn on our still again. And again, we're going to collect around 100 mils of distillate. And until that happens, I'm going to go ahead and pause it, and then we'll come back and talk about how we titrate and do the math on this. And voila, just like that, we're back. So as soon as we get our 100 mils of distillate, we go ahead and turn off the still. And we'll go ahead and empty the sample out and give it a little rinse down just to make sure it's all nice and clean for the next person. All right. Do that, and I'll go ahead and turn off the condenser so we can have it as quiet as we need it to be. So our next step is to do our blank, which was the first one I did with just the water. So we're going to titrate that back to its palest pink. So we're going to go over to our 0.01 molar sodium hydroxide and put a little bit in until we hit back to that pale, pale pink. I think we're probably already there. So it's not a whole lot. It's only a little bit in this particular instance. We've got that nice pale pink. See how it's nice and pale pink and persisting for 30 seconds? And our blank in this particular instance is exactly 1/2 milliliter. So we'll remember that, and then I'll go over and do the math and show you how this works. So this is our wine sample, and so we're going to go ahead and test that right now, and we'll do a titration on that. So we're starting at 1/2 ml, and we're going to go ahead and titrate this sample. And notice how it goes away pretty quick because we've got some acid in here that came over. And this is a pretty big titration value usually. So sometimes you can just let it run a little bit. Oh, we're starting to get pale pink. We want to make sure it persists for a little bit. See how it disappears? So I want to get a little bit more in there. See if we hold. Not quite. A little bit more. For that nice pale pink to persist. And it's still fading out a little bit, so we're going to do just a drizzle more. And that's a nice pale pink. Looks like we're persisting quite nicely, so we're going to call it at that amount. And so we're at 10 milliliters. 10 milliliters. So I'm going to go ahead and pause it and go show you the math. Unfortunately, my phone is recording backwards, but we'll have to do just our darndest here. And this isn't exactly the best ink to be using. So our titer value was 10 mils minus our blank, which was 0.5. That means our volume of sodium hydroxide is 9.5 milliliters. Then we'll take that and multiply that by 0.6, which is our VA in grams a liter per milliliter. So let's go ahead and do that. So that's 0, the 3. So that is that's 0.57 VA in grams per liter. So that's your answer, is 0.57 grams per liter of VA. If you were to get that titer value. That's the math. That's how we do a volatile acidity.